We are so familiar with that the physical space in which humans live and work has far-reaching implications on the nature and quality of everyday life and experiences. As Winston Churchill put it, we shape our building, thereafter our building shape us. Understanding the space surrounding us has been a challenge for many disciplines. Architects shape space by designing buildings and cities. Psychologists and cognitive scientists how humans understand space and how they behave in space. Computer science needs to find a way to responding and computing with the space about its structure and perceived behavior and function. Now it's a time to actively foster interdisciplinary connection to understand better the relation of design space, human cognition, and computation for design and artificial intelligence. But considering the new technologies and the system of next generation design with perspective on multimodal design analysis and behavioral and functional simulation and interaction design issue. My research moves in an interdisciplinary context between architect, neuroscience, social science, computer science, that it take advantage of the study of brainwave and facial expression to detect the emotional state of individual as related it to interactive public space and encourage social interaction between users. New digital media technologies have penalized face-to-face interaction and the practice of non-verbal actions. The crisis has been reflected in the architectural field, where public space risks being deprived of its nature as a place to live and communication. Therefore, I ask myself if it could be possible to create a new public space designed as a tool for sharing and the social development in which humans, maintaining the individuality, they can interact empathically. This can be achieved by inserting the intelligent component in public space integrated into the architectural projects. So this intelligent component related to exploit of users' brain waves thanks of using the brain-computer interface technology and electroencephalography. What the research tries to prove is how this type of technology can be applied to interactive architecture, defining a new transdisciplinary methodology that is able to combine the tools of the architecture with those of neuroscience in order to satisfy not only physical and functional needs, but also those emotional and psychological. The research is structured in 4 parts, each concerning a macro topic. The first provide overview, historical and argumentative of the neuroarchitecture and specifies which among the existing methods are considered the most effective and which one will be in depth as support for the proposed methodology. Particularly, 3 approaches will be considered as a principal approach that they form the spine of the entire research. The first approach proposed by the Psycho-Laboratory Ladowski technician of the CUTMAS and the reassumed from the eventualist architect of Sergio Lombardo, who has determined a methodology to understand the relationship between the perception of form and physiological reflection on observers. The second is translating neuroscience into design of Eve Edelstein, which related to biomedical data to neuroscience in order to obtain new tools to change the built environment based on the answer to external stimuli. The third is the neuromorphic architecture by Michael Arby, the idea of incorporating an artificial brain to the fundamental part of the building. This embodiment is created by creating an interactive infrastructure which, for example, could contain intelligent device equivalent of the hippocampus. An important prototype for neuromorphic architecture is the ADA Pavilion, the most important realization of a network neuronal device with an interactive infrastructure. The second part of the research described a design strategy in position to realize this new and more advanced conception of intelligent and emotional architecture space with focus on coding. The research integrated into the theory of extended mind thesis by Clark and Charmels, going toward the concept of the Umwelt environment treated by Jacob von Uxel and taken by Catalan, according which each word depends on the relationship between living organisms and environments that build a particular Umwelt. The relationship between personal space and interpersonal and extrapersonal is the fundamental approach in my research. To analyze this aspect is necessary to collect the non-verbal data, which play a fundamental role in social communication at a subjective and intersubjective level. This lead form the extended mind to extendatory emotion. The extended mind is obtained through the extension of the feelings and emotional state. This operation could be possibly only thanks of emotional consciousness, which underlies the synergy and empathy. Architectural environment can be equipped with powerful sensors capable of interpreting of unintentionally signals created by humans, in particular the brainwave, through some technologies such as brain-computer interface and the variable technologies such electroencephalography, and also facial expression according to the principle of neurostatic. Particularly in this research, the variable technology and treatable and extended body is interesting in the form of prostheses. In other words, variable technology device help us to extend it in the surrounding environment and able to lead directly the artificial intelligence incorporated in the building, thus consisting a bridge between individuals and building itself. The third part deals with the study of interactive public space, focusing on the aspect of communication and social interaction. After study of different types of the public space, I try to clarify the role of architecture in social interaction with dwelling and focusing on the concept of affordance by Gibson, as treated by Kefferstein and Rietveld, that suggests a new socio-cultural practice for identify the new possibility for action provided by material environment. The concept of affordance applied as a basis for the interactive design through numerous case study of interactive public installation. In this point, the research wants to demonstrate how architectural space is able to implement in the scope of interaction with technological installation, creating the feeling of connection and communication. In this step, the approach of computing for design is necessary. In the last 2 decades, several interdisciplinary initiatives comprised of computer science, engineering, psychologists, and designers have addressed the application of artificial intelligence techniques for solving critical problems that emerge several stages of the design process, such as design conceptualization, functionality specification, geometric modeling, and other things. In this research, computer for design is characterized in the relationship to the domain of artificial intelligence and design, and developing the tool system and framework for design system that go beyond contemporary technology design paradigm and practice, and stir this environment toward the desired enabling technology of the future of architecture. Particularly in the Brainwave project designed by Anastasia Victor in 2012, demonstrated the way of the user that user can interact with the environment. And with this simple example, you can see the different way that interactive architectural design is able to use the coding and artificial intelligence and using the various data from other science like neuroscience. In this project, affective and cognitive state detected through at emotive epoch while user is syncing a color. Therefore, it's possible to adapt the color of the environment according to the signals transmitted by the brain, varying in the tones and the intensity of the color. The receiving device at the stage is in much more advanced, able to read a more emotional state. Human-computer interface technology, in fact, allow to us hundreds different sensors sensitive to light and movement, thermal and biophysical detector that detected heart rate, gesture of the hand, and movement of the eyes. Furthermore, in the construction process of Internet of Things, we are able to have the interaction with networks of sensor feedbacks. In this way, the architect is able to change and adapt to variety of pre-configured and generated state through environmental planning. The last part proposes a design solution of effective use of interactive technology as well as artificial intelligence software and hardware, starting from various case studies. The technologies that consider is the research are brain-computer interface, electroencephalography, thermal and biophysical sensors, and human-computer interface. Until now, this technology have been applied individually at the single person. The goal of this research is applying them for the first time in interpersonal communication. The interaction between the private brain and social brain, intra-brain communication is based on emotional regulation. The connection with the other leads to sharing of affective state through visual attention, motor acts, and expressive mimics. Take over such unconsciousness signal, we can design intelligent public space with the ability to increase the social interaction based on the emotional stage and the facial expression of the users. Thus, the study presents the previous section of the brain imaging and brain-computer interface technology go toward the study of social brain imaging and hyperscanning to access an emotional state and social interaction. The research also carried out the study of the exchanging information among the various subjects in real time with the collection of the data emotional state in public place based on interpersonal and interbrain behavior by extending this possibility to public space. The first project is the public space, such a bar or restaurant, that based ideal, the base idea of this project is using similar technology that's applied in the Russia ICT Pavilion of 2012 Biennale of Venice, built as a set of bricks, each provide with a QR code to obtain the desired information. To do this, it's necessary to use an external device such as a tablet, which reacts to direct command. Now, the idea in this level is instead of tablet, we can use the future step of technology such as variable technology and make it react to the emotion or brain waves to have immediate access to infinity of data. The public space is the project intended as a smart and intelligent space able to put a group of people together at a table for meeting and face-to-face communication. Through of emotive EEG device and brain-computer technology, then the space are able to compare their brain activity and facial expression to improve social exchange during the meeting or to indicate a new association between individuals based on their harmony. I'm currently carrying out a data collection experiment in collaboration with neuroscientists and engineering with two different group volunteers of the age of 25, 35, and over 45, a selection of a famous painting which have as their object facial expression and places of social interaction, recording the reaction of measure the emotional state. The ultimate goal is to apply this data to obtain an architecture able to identify the people who respond with the same emotional state and put them in contact with each other. For example, using the various technology able to use the light effect on the wall and also on the floor. Another useful project for this research is the Mutual Wave Machine, is a project in 2013 in the field of neuroscience of social interaction, which allows us to synchronizing the brainwave of two people. These are enclosed in an intimate capsule and immersed in an audio-visual environment that reflects their shared brain activity. During the experience, measured synchronization is reflected in a measured vivacity of the audio-visual model, while the lack of synchronization tends toward weak noise and static image. What we try to demonstrate is therefore how an architectural space that has a minimum capacity to synchronize brainwave between users can be realized. The second project concerned the technological implementation of the Allianz Arena Stadium designed by Herzog de Meuron. The typology of the stadium is ideal to create an interactive public space that can improve social interaction since it has a precise function and welcome people who share a single interest. Furthermore, it offers numerous insights on safety, follow management, and the outdoor user space. As Friedman argues, crowding is not itself either good or bad, but depends on the context in which social interaction take place and the relationship between users, the space. Therefore, through the density tools, interactive public space can find a strategy to elevate positive feeling and mitigate negative ones. A first application in the Platform 5 project by Jason Bruges on Sutherland Station with an interactive screen. Here we propose forward a step by integrating the brain-computer interface and electroencephalography technology into the architecture. In the case of the stadium, you can understand the state of stress, aggravation of the fans, avoiding the danger and allowing the environment to exert a positive influence on the users. Furthermore, the interactive space would help to relax the mind or entertain spectators with digital games, colors, music, and taking advantage of the affordances of the space in personalized way. There are several possibility extension of the research. Practical application can be to public security, to school, to families, or social groups, or even to traditional public space. Also, the study of biological material that can be used as an extension of the extension body, and the deepening of variable technology and their connection with architectural interactive space.